Alright, we are taking a look at section 3.5. Our learning goal here is to be able to solve systems of nonlinear equations. We also want to be able to solve quadratic equations by graphing. So we're going to be doing this with algebra as well as with our graphing calculator. So if we have an equation of f of x equals g of x, we can write a system of two equations, y equals the f of x and y equals the g of x. We can graph those, and then the x value that makes these true, that's going to be our solution. So let's look at an example here. So it says I'm going to get rid of everything in here, it says to graph these and find the solution. So we're going to do 1/2 x squared minus 3, and we're going to do -4 minus 2x squared. Alright, I'm going to do a zoom 6. There's this parabola. Here comes the second parabola. Alright, do you notice how these do not intersect at all? When they do not intersect, there is no solution. You may not write no real solution. There is no solution, period. Whether it's real or imaginary, no solution. Alright, let's look at the next one. Now this is going to be a parabola shifted to the right 2. And then we know this is going to be a line, the second one. So we've got a parabola and a line, and let's see where they intersect, if at all. Here's our parabola. There's the line. Ooh, looks like they're intersecting just right there. So let's check it out. Second, trace, graph, calculate intersection. We're going to get super close to that. It could actually be two solutions. It's hard to tell for sure. Enter, enter, enter. And it tells us the answer is 2. So then the solution to this then is going to be when x is 2, y is 0. That's going to be the solution set for it. I could plug it in and check it. 2 minus 2 squared, that's going to be 0. Plugging in here, 1/4 times 2 is going to be 1/2 minus 1/2, that's 0. So that's the ordered pair that works. Now, if you're not sure about that, watch what I could do. I could go in really close on my window, like -2 to 2, 3, let's make it that. And so I'm just going to get in here real close, just to make sure there's no other solutions. So there we've got that. Alright, and see how we can see it's just hitting in that one spot. So we just have that one solution. Alright, solve the systems of nonlinear equations by using the graphs below. Alright, well I can solve this one. I can see that right there is a solution, and that is at -1, and then this is going by, let's see, 2, 4, 6, 8, 10. So -1, 10. -1, -10 should be a solution. I like to check it. -1 squared is 1. Okay, let's check that again. So -110 is supposed to be a solution to this. Oh my goodness. Oh, this is not related to that. Okay. Disregard. Let's go back up here. This solution is -1, -10. This solution is 2, -10. Completely different problem. Alright, this one though, what's our solution going to be? No solution at all. Alright, now let's work on this one. So if I want to do this one by substitution, I've got this equation which happens to be a circle, and I've got this equation which is a line. So what I'm going to do is I'm going to take this y value and I'm going to substitute that in right there. So I'm going to have x squared plus -x plus 4 squared must equal 16. So I've got x squared plus, to square this quickly, I'm going to do it off to the side just to show you the pattern. So to square that, I'm going to have to do -x times -x, that's positive x squared. This is going to be -4x and -4x, that's -8x, and then Positive 4 times positive 4 is 16. The quick way to do this is to square it, multiply and double, and square. That's always going to get you to the solution. So now we've got 2x squared minus 8x. Subtract 16 from both sides is 0. Factor out a 2x, x minus 4. So we're going to have a solution of x equals 4 and x equals 0. So now I know that those are my two x values that work. Now I've got to find the y values that would correspond with them. So if I plug in 0 for x here, I'm going to get 4. If I plug in 4, negative 4 plus 4 is 0. So those are going to be the 2 points that make these true. All right. Solving this system by elimination. To do elimination, I want to get everything lined up. So I'm going to rewrite this one, and I'm going to line up all the variables. X squared doesn't have a match. Negative 7x does. I'm going to go ahead and subtract 11 here and make it negative 12. So I'm actually going to have negative 12 right there. What else? We're going to need to bring this y over here to make it minus y. So this is an equation that's equal to that one. Look at it again. X squared minus 7x. I brought the y over, so it was minus y. I had to get them lined up, so I had to take the 11 over here, so that's why it's negative 12. Alright, so now what I want to do is I want to eliminate a variable. So if I add these together, I'm going to get x squared minus 8x. These would cancel out, equals negative 16. So x squared minus 8x plus 16 equals 0. Factor. X and x, 4 and 4, minus minus. So x equals 4 is our solution. So now I have to plug that back in. So I can plug it back in anywhere, but this looks easiest. So I'm going to do negative 4 plus y equals negative 4. And so adding 4 to both sides, I'm going to get 0. So that's going to be the only solution right there is 4, 0. Solving this one by elimination, I'm checking it out. If I just go and add, nothing's going to eliminate. So if I want to get rid of these y's, I'm going to multiply by negative 1 everywhere here. It's already lined up in order. So y plus negative y is 0. 8x squared plus 14x plus 21. I'm hopeful that this factors. I'm going to multiply those two. 8 times 21 would be, what, 168? So are there numbers that multiply to be 168 and that would add to be 14? Alright, so we know 21 and 8, let's see, what's that going to be? 4 times, got to work through this, 8, what else will go into that? Okay, so if I know it's 8 times 21, I can go like this and get some other things that might work, some other factors. So I could use 24 and 7. Okay, that's it right there. See, what I'm doing is I know that it was 8 times 21 to start with, so I know 21 is going to be 7 times 3, so I know that these are the factors, and I got lucky because 24 and 7, actually those would subtract though, wouldn't they? So I don't think those are going to work. We're going to have to keep going. Yeah, 24 and 7 wouldn't give us 14 anyway. Keep going. 4, 2. So what about, let's see here. We could get 12 and 14. We could get, okay, we're going to do this instead. I would think these would come out even. I'm going to see if this will ever equal 0. Sometimes when you're trying to factor, it's just, it's just hard to see. What would be, what did I leave out? Okay, maybe this must be no solution then. I'm going to go up further. Because of this plus 21, might be up there higher. Okay, so there's the parabola. Yeah, and it definitely does not ever equal 0. So it can't be factored. And you know, I could have gone through, I was just trying to factor it, and that's kind of the process you go through. But I also could have just started using the quadratic formula. You know, x equals negative b plus or minus the square root, b squared 196 minus 4 times 8 is 32 times 21. See, right there, I'm going to get a number that's going to be larger than 196. So this would be imaginary under here. And remember how if we get imaginary solutions, that means that for this, these are never going to intersect, so therefore it's going to be no solution. And I don't write no real solution, because when I get an imaginary, when I get a negative number under here that makes this an imaginary kind of thing, that just means that these two graphs would not intersect. There's no solution, period. All right. And guys, sometimes you have to do that. You know, you kind of struggle through it. At first you think it might factor, then you see it doesn't, and then you just do other things until you can figure it out. Consider the following system. X squared equals 9 minus y squared, and then x plus 2y equals 2x squared plus 7 plus x. Which method would you use to solve the system? Well, when I look at it, I might be able to get rid of, I can't get rid of the y squared there. And I think what I want to do is try to get rid of, the x's. Let's see what happens here. What I'm going to do is I'm going to get it into standard form. And I'm going to get this one, it's going to be, what, 2x squared. Let's put it, and then these x's are going to cancel out. Those are going to end up being just 0 if I subtract x from both sides. And so then I took care of that, and then I'm going to put this plus 2y equals 7. Alright, so I want to get these, I could probably get these x squareds now to go away, couldn't I? And just be left with y's. That's what we're going to want to do. We're going to want to multiply that by negative 2. Okay, so which method would you use to solve? I'm going to use elimination. And that's because I can eliminate all x terms. See, I already got rid of the x's at the very beginning, and now if I multiply this by negative 2, I can get rid of the x squared and just be left with y's. It doesn't say we have to do it, so we don't really have to do the rest of it. Would you have used a different method if the system had been like this? Let's see. So if we subtract x's, the x's are going to be gone. Now I've got a y and I've got an x. I've got x squared and an x. No, I would not use a different method. But we would, do you see, this time I couldn't eliminate the x's because I've got an x squared and an x, but I could, if I did it, you know, multiplied the right way, I could eliminate the y's. We could eliminate y's. The y with elimination. Now, we don't have to use elimination on here because I could also put this into the calculator. I could solve this for y equals, and I could just do, I could get, what would I get? I'd bring, you know, I could solve each of these for y, and I could, you know, use substitution or something else. But, I mean, I think you could use elimination just as easy as substitution. we could also use substitution. All right, so done with that. That's just kind of, trying to figure out the best way to do things. This one, I think both ways are just as good, substitution or elimination. This one, you would really pretty much have to use elimination. I think that would be the best way. You could actually solve this for x squared, and then you could replace this x squared with what you get, but that would be a lot more difficult. Okay, looking down here, the sum of two numbers is -5, and the sum of the squares of the two numbers is 17. So I'm going to call x one of my numbers, first number. Y I'm going to call my second number. And the sum of them, so x plus y, has to be -5. The sum of the squares of the two numbers, so the square of my first would be x squared, the square of my second would be y squared, sum means add, must be 17. What are the two numbers? Alright, we cannot use elimination here because I don't have any like terms, so I'm going to have to use substitution. I'm going to be forced to solve this for y. So y is going to be -x minus 5. So now I've got x squared plus, here's my y. I'm going to want to replace that with -x minus 5. So this stays the same. Here's going to have to be -x squared is x squared. I multiply these two and I get positive 5x, and then I have to double. And then I square that. That's the quick way to do it. So now I'm going to have 2x squared plus 10x, bring this over here, plus 8 equals 0. Divide by 2, x squared plus 5x plus 4. Are there numbers that multiply to be 4 and add to be 5? Yes. Nice, so we don't have to use quadratic formula. Plus plus. Okay, so then our solutions are going to be -4 and -1. Now, that doesn't mean that those are my final answers. What that means is that -4 is a solution, but I'm going to have to plug it back in. -4 is going to be 4, minus 5 is -1. But we could also have x be -1. -1 is going to be 1, minus 5 is going to be -4. Well, these are actually the same answers. But you do have to check that out because, it could be that they're not. So I can get rid of this. It really means the same thing as that. So I want to check it. The sum has to be -5, yes. If I square that at 16, square that, it's going to be 1, and that works out too. All right? So that lesson was all about the quadratic formula, but still, don't just use a quadratic formula all the time. If you can factor, factor, because it's a lot faster and, it just makes life a little bit easier for you.